Hey, we're back. We're about to go into section 9-2 for adding and subtracting rational expressions. A couple of things we're going to make sure you remember. Way back in the day when you were in elementary school, you'd do problems like this. 4/3 plus 3/2. If you remember, what you had to do is get a common denominator. Yeah, common denominator. We ended up multiplying top and bottom by 2 on this fraction, and multiplying top and bottom by 3 on this fraction. It's really important you're actually multiplying top and bottom each by that factor, because that's a value of 1, and that's why it's legal to do. When you would do that, you'd end up with a common denominator of 6, right? So we have 6 for denominator, and in the numerator then we have 2 times 4 is 8, and 3 times 3 is 9, so we have 8 plus the 9 over the 6, and you'd get 17 sixes. We can leave it like that. We like improper fractions for what we're going to do algebraically. So, if you recall, when we would look at something like this, what if you had 3/4 plus 1/2? Well, you could do a denominator of 8, but 8 can end up causing a lot of problems later if you have to reduce, especially algebraically. So what we're really looking for is the least common multiple. What is the smallest denominator you can get away with here? Look, the easiest denominator, the smallest denominator is an 8. So, I'm sorry, no, it's not an 8. It's a 4. We don't want to use an 8. We want to use a 4. So all I have to do is multiply top and bottom by a 2 on this one fraction. And since I'm multiplying by 1, it's okay. I'm not changing the value. I'm changing the way it looks. So I end up with 3 plus 2 over 4, which ends up being 5/4. Well, that's what you did in probably fifth and 6th grade. Let's talk about this one. Algebraically, if we're adding rational expressions, this is our first example. If you have 3y over 2x cubed plus 5z over 8xy squared, we need a least common multiple. What would be a smart denominator to use here? Well, I don't want to use 16. The smallest number I want to use here is probably the 8. I want the common multiple that would be the smallest. So I'm going to go with a factor of 8 in the denominator. What's the least number of x's I can get away with and be fair would be x cubed. And I have to account for the y squared. So my new denominator is going to be 8x cubed y squared. Now we go back to the original problem and we ask ourselves, what do I need on top and bottom? If I'm trying to get an 8x cubed y squared to be fair, what do I not have here? Well, I have a 2, I need an 8, so I'm going to have to multiply top and bottom by a 4. I also have an x cubed. Now I'm okay there, but I'm going to need a y squared. By multiplying top and bottom by the same factors, I'm changing the way this looks, but not really changing its value. So in the first term, I have a 4 times 3 is 12, and I got a y squared, and a y becomes y cubed. Plus, what do I need in this factor? Well, I need an 8, and I have one. I have an x, but I need x cubed, so I'm going to need to multiply top and bottom by x squared. I have a y squared, so I'm set there. By multiplying top and bottom by x squared on this term, I'm just changing the way it looks. It ends up saying 5x squared z. The last thing we need to do, and it's really an important step, is you take a minute to think about, is there anything I could possibly, after doing all of this manipulation, is there something that maybe would factor out of this? No, there's nothing common between the 12 and the 5. Y's, x's, and z's, so I am finished. I have a 12y squared plus 5x squared z all over the common denominator of 8x cubed y squared. Remember that these are terms in the numerator and they have no right to reduce with anything in the denominator. Technically, there's parentheses locking them in together up in the top.